Okay.
Hi, Rachel.
Hey, Rachel. Okay, so we're moving on to derivatives of trigonometric ratios. So before we were taking the limits, right? So if we start off, so this one says first principles can be established, or can also establish the derivatives of trigonometric ratios. So remember that we define the derivative as the limit as h approaches 0 of f of x plus h minus f of x over h. Like way back when. Kind of remember that?
Before Christ.
Yeah, it was a long time ago. Okay, I'm going to go pretty quickly through this part. So we just need to kind of remember a few identities to figure out what the derivatives will be. So from last lesson, we knew that the limit as h approaches 0 of cos h minus 1 over h, we showed that that's equal to 0. We also showed that the limit as h approaches 0 of sine h over h is equal to 1. So we can use that. And we're going to prove
Sine h minus 1.
what the derivative of sine x is. So if we want to figure out the derivative of sine x, then we just need to take the limit as h approaches 0 and put it into that format. So if we do that, we can say, okay, the dy dx is equal to the limit as h approaches 0.
Okay, time to write all this down.
Actually, you know what? If you don't want to write it down, I'm okay with it too. If you just want to follow along with me for a second.
Okay.
Because in the end, I'm going to prove something, and you just need to be able to take my word for it, I guess. Okay, so the limit as h approaches 0. And then I've got sine x plus h minus sine x over h. One little trick is we can say that sine x plus h, that's the same thing as sine x cos h plus cos x sine h. Just one of our identities. And then minus sine x again on this side, right? All over h. Then what we can do is kind of rearrange this. So if I just take sine x cos h and the minus sine x, and I kind of put them together down here, that's what I got in blue. I put all of that together. Then what I can do is I can factor out a sine x out of here, right? The ones written in red. So that would end up looking like this. Sine x times cos h minus 1 plus cos x sine h all over h. Then all I'm going to do is I'm going to rewrite this whole expression up here. I'm going to split up into two limits. So I'm going to just take this part over h, and then that part over, like the cos x sine h over h. So yeah, so we got 2 different parts here. So that one and that one. Okay, so yeah, we've got those two terms there. Then what I can say though is I know that cos, like the part in green here, that's equal to 0. That's that, right? So I know that this first term, sine x times 0, that's just...
What that equal to 1?
No. Equal to 0.
We wrote yesterday here that cos theta minus 1 over theta equals 1.
No, it should have been 0. If I did, then that was a mistake.
Alright.
Okay, so that's equal to 0, right? The part in red here. And then this, I know that sine h over h, that's equal to 1. So that's that, right? So in the end here, I've just got 0 plus cos x. So in the end, when I took the limit, or the derivative of sine x, the derivative is just cos x. So this is our first derivative. Alright, now thinking about this graphically, so it says let's use the concept of tangent line graphically to find the derivative of cos x, sketch the curve of cos x. So if we figured out the derivative of cos x, we're really talking about what the slope is at any given point. So we did that. So what we can do here is figure out, what I would do is figure out where is the slope equal to 0. Those are going to be critical points that are going to be easy to plot on our graph, right? So we've got equal to 0 there. It's equal to 0 there. Slope is equal to 0 there and there. So if we're going to graph the graph of the derivative of that, really all we got to do is say, okay, at this point here, that's going to be 0 on my new graph. This is going to be 0 on my new graph. 0 on my new graph. 0. And 0.
Shuffle the whole thing.
So yeah, just so we don't get confused, this blue line, that was cos x, right? Or y is equal to cos x. So now we want to draw dy dx, or the derivative of cos x. So that is going to be, so we can see we made our points. So if we just start here, we know what, starting at that first point, it's going to come down here, it's going to cross the line, it's going to go up, it's going to cross, go up, and down. So our derivative is the green line. Okay, so that's our new graph, right? Can you tell me what that graph kind of looks like? Have you seen that graph before?
Sine wave.
Yeah, it's sine wave, right? And more particularly here, if we kind of see, okay, like if we looked at when cos is equal to 0, so cos is 0, what am I saying the graph is at? 1 is, it's actually -1 down there. Right? So, and again here, right, when cos is 0, so it's -1. What the derivative of cos ends up being, so the derivative of cos, so ddx of cos x is actually equal to negative sine x. So we've got 2 so far that we just have to remember. We've got the derivative of sine x is what?
Cos.
Yeah, derivative of sine is cos. The derivative of cos is negative sine. So that's the 2 new things that we've learned. Now we just need to use those in questions. One thing we have to remember though, like if we look down here, this looks all confusing, but it's really just a chain rule. So if we had ddx of sine, u, so some other variable, then that's going to be the derivative of sine, cos, times du dx. So the chain rule, right? You're doing the outside and the inside is all that's saying. And then this is saying that the derivative of cos would be negative sine u times the derivative of u, du dt, or dx. Alright, now we got to do these problems. I forgot to leave you space, but I gave you extra pages so you can write them down. Let's do... Actually, let's go back and do A down here. Sorry, I'm kind of clicking all over the place. I'm going to do A down here. You guys can write it on a different page. So A was y is equal to sine 2x. So this shouldn't look that bad at all. This is just a chain rule. So the derivative of sine, what did we say the derivative of sine was?
Cos.
Cos.
No,
So it's going to be
y
cos
prime, right?
2x, but then we have to multiply it by the derivative of the inside.
So it would just be 2.
Yep. So times 2. So this just becomes...
Is that y prime?
Yeah, y prime, yeah, sorry. So y prime would be equal to 2 cos 2x. Not too bad, eh?
No. No, it's not, but that's like the first question.
But it's all the same, so now we've got, again, chain rule.
Oh, you gave yourself space.
Yeah, I did.
People's children.
Okay, so the derivative of this one, so y prime is going to be equal to, well, I need to take the derivative of sine first, because that's like the outside. So the derivative of sine was cos, and then still x squared minus 1. But then the derivative of the inside. So the derivative of x squared minus 1 is
2x.
2x. Yeah. So this just becomes, should be a y, is equal to 2x cos x squared minus 1.
Hey.
Oh, you were done?
No.
Alright.
Not gonna be.
Okay, y is equal to x sine x. So we've got something times something else. What do we need to use?
The product rule.
We do. So we've got an f and a g. So I'm going to say f is equal to x. F prime is equal to 1. G is equal to sine x. And g prime is equal to cos x. Now you could say cos x, times 1, right? Because it's derivative in the inside, but whatever. Okay, so if we just use our product rule, y prime is equal to f prime g plus f g prime. So y prime is equal to 1 times g was sine x plus f was x and g prime was cos x. And that's really all we can do. So that's just equal to sine x plus x cos x. Okay,
Happened to D.
did I miss D?
You missed the D.
I missed it. There it is.
Oh, we could have skipped that one.
Should we skip that one?
No.
It's really just going to be the quotient rule now, right?
Yeah.
So now we've got f and we got g. So f is equal to x, f prime is equal to 1, g is equal to sine x, g prime is equal to cos x. Okay, so, and the quotient rule is y prime is equal to f prime g minus
G prime f over g squared.
f g prime over g squared. Okay, so y prime is equal to 1 times sine x minus x times cos x over sine squared x.
It's not sine x squared.
Same thing, actually. That's kind of a good point to bring that up. We're going to start doing that a lot, where if I look at the way that's written, that's the same thing as sine x all in brackets squared. We just kind of typically like to write it like this instead.
Fine.
Alright, done that one. Okay, E. Now we got the chain rule again, but remember this can be written, like I just said, y is equal to cos x squared. That might look a little bit more familiar. What would we do if we're doing the chain rule? How would that look?
2 cos x times
Right, 2 cos x, yeah.
1.
So 2 cos x, that's doing like the bracket part first. And then times the derivative of the inside. So what's the derivative of the inside now?
Oh, negative sine.
Negative sine x. So then, if we really simplify this though, this ends up becoming negative 2 cos x sine x. And one of our identities is that 2 cos x sine x is just equal to sine 2a. Or sine 2x.
2x.
Yeah, sorry. 2x. So in the end, this just becomes negative sine 2x.
Negative 2? Oh, no, we leave the 2 up there.
The 2 was part of that identity. Yeah.
Yeah.
Okay, G. I gave myself too much room.
Come back.
E. There's no F.
There it is. Y equals cos ax plus b.
No, I have that on mine.
It looks awful.
Oh. And I've got somebody else's. Okay, apparently your guys' copy has an F in it. It's not in my copy, so let's do G though, so skip to G. So if we say, again, we just got a chain rule, right? So we got to do the, well, what would we do? So the derivative of what first?
The inside.
Nope, outside.
Outside.
Yeah, so the first derivative is going to be negative sine x, and then times the derivative now of the inside.
Is that not like quotient or product rule, I mean? Because it's cos times sine x?
It's not cosine, it's saying that like cos of sine x. So it's like that sine x is like the angle that it's talking about.
So you missed a 2.
Yeah. Okay, so that's really it. You can rewrite that in a different, like, cos up front if you want to, but that's that one. Now, okay, differentiate implicitly sine x plus sine y is equal to 1. So remember implicit differentiation?
I remember the name.
So I'm just going to rewrite this again. So sine x plus sine y is equal to 1. What we're going to do is we want to differentiate the whole thing. So this is going to be, I'm going to take d dx of the entire thing. So now when I take the derivative with respect to x of sine x, that's going to be just like normal, right? That's just going to be the derivative of sine x is going to be equal to cos x.
Yeah.
Plus, now I've got the derivative
Oh,
of...
then you have to have like sine y,
right.
y dx?
Yeah. So now I've got derivative of sine y though, with respect to x, so we just need to apply the chain rule to that too. So this becomes still the like normal derivative, so it would still be cos y, but then you have to tack on at the end that dy dx. And then that's equal to the derivative of 1 is 0.
0.
So then just rearranging this becomes dy dx is equal to negative cos x over cos y.
Now we know.
Now we know. Okay, we got one more question to do, and it's kind of a longer one, so I am going to stop this video here and do the next one in a new video.